Okay, this is Algebra I Lesson 18. We're talking about like terms today. We've already just determined what a term is. A term is separated by a plus or a minus. So in this example, I've got three terms. I've got one minus and a plus. I've got one, two, three terms. Now we said we're going to learn what like terms are because we're going to learn how to combine like terms. To be a like term, you have to have the same variable or variables raised to the same power. So let's just pull out the variables. Let's ignore the coefficients that we learned last week. What the coefficients are: xmp, pmx, mxp. Are these alike? At first, they don't look like they're alike, but they really are like terms. Let's assign a value to x, p, and m. We're going to assign x is equal to 1, m is equal to 2, and p is equal to 1. I'm going to go back and substitute these values into these terms. So I've got 1 times 2 times 1, and I get 2. And I get 1 times 2 times 1, and I get 2. And then I get 2 times 1 times 1, and I get 2. So these terms are alike. Even though they look different, we have a property that says the commutative property. X times m times p is equal to m times p times x. It says we can change order. It does not change the product of the problem. And this is the commutative property of multiplication. So once we do that, we also learned the distributive property last week. And basically, what our distributive property said, if I have BA plus CA plus DA it is equal to B plus C plus D all times A. I know you can't see this. I'm moving this computer. Times A. Right? So what does that mean? Well, let's look at this exact same problem. We show that they're like terms. So basically it says we're going to take out, since they're like terms, we're going to take out the variable from each term, and what's left is the constant or the coefficient, which does not necessarily have to be a whole number, but usually is. Can be integer, can be a fraction or a decimal. So we have 4. Remember the sign to the left of each term goes to it. So minus 2 plus 6. So all this times that, and then I do my order of operation, and I get 4 minus 2 is 2 plus 6 is 8. So I get xmp8, or 8xmp is the proper way to write it. And that's what I had earlier. Or I simply add the coefficients. Let's see if that works. 4 minus 2 is 2 plus 6 is 8. 8xmp. So those are just different ways to look at them. So let's go ahead and go straight to the examples and look at example 18.1. It says let's go ahead and simplify. Simplify by adding like terms. So we've got 3x plus 5 minus xy plus 2yx minus 5x. So basically we have to look at these. How many terms do we have here? We have 1, 2, 3, 4, 5. We've got to determine which ones are like. So let's just pull out the coefficients. The variables. Leave the coefficients. So we have x here. We have nothing there. We have an xy, a yx, and an x. Which ones are the same? Well, these two are the same. They're both x's. And these two are the same. Because of my commutative property of addition, since I can move things around. So I can do 3x minus 5x minus xy plus 2yx plus 5. And don't forget, the sign to the left of the term is the sign of the term. This is a positive 5. This is a negative xy, positive 2yx, and minus 5x. So now I simply have these two are the same. So I've got what? A positive 3 and a negative 5. I simply combine the coefficients or the constants. So a positive 3 and minus 5 gives me their different signs. I find the difference is negative 2, and you keep the variable or variables. These are the same. They don't look the same, but the commutative property multiplication says I can flip them. Doesn't matter. So I can change this to x, y. So they're the same terms. A minus is an implied 1. There's no coefficient here. So it's a negative 1 plus 2. So it's a plus yx. And then plus 5. And that's as far as you go because none of these have it. This has an x and that has an x, but this has a y. That does not have a y. So these two, the bottom, are not like terms. So let's look at another problem. Let's try and get some of this glare out. Okay, so let's look at example 18.2 or 18.4. Simplify by adding like terms. So I've got 3x minus x minus y plus 5 minus 2y minus 3x minus 10 minus 8y. You're like, whoa, that's a lot. But when you have problems like that, you have to make sure that you do that you don't forget any terms. You've got 1, 2, 3, 4, 5, 6, 7, 8 terms on this problem. Okay, you can't leave one of them out. So I know I haven't, for me, and you don't have to do this. This is a 5, and I'm going to go to anything with the variables. I'm going to do this to it. So this is an x. This is an x, this is a y, this is a y, this is an x, and this is a y. So I know I have 3 y's that are the same and 3 x's. So I'm simply going to take their coefficients. What are they? I have a 3 here, negative 1, because there's nothing that's implying negative 1. Negative 1, this is a positive 5, but it's just a constant. Negative 2, negative 3, negative 10, and negative 8. So this has a positive 3, a negative 1, and a negative 3. So my two 3's are opposites. You have a positive 3 here and a negative 3 here. So those cancel out to 0. But then I'm left with this. So that's a negative x. So I've done that one, I've done that one, and I've done that one. Now I'm going to do my y's. I've got a negative 1, a negative 2, and a negative 8. They're all the same sign, so I simply add these coefficients. 8 plus 2 is 10 plus 1 is 11, and you keep that sign. So minus 11y, you keep the coefficient, the variable. Okay? So now I have what? I can't forget these two. Those are just simply constants. And I have a positive 5 and a negative 10, which gives me a minus 5. And your answer is simply negative x minus 11 minus 5. Let's do one more. Let's do 18.5. So basically, I'm going to stop here and tell you for your code on homework lesson number 16, I want you to put the initials PJ on the top left-hand corner of your homework. Okay? Don't turn that in. The initials PJ. Go ahead and circle them because sometimes you're a little messy with your problems. Put that on the top left-hand corner. Is your code lesson 16. Homework lesson 16 is due on Monday. I want PJ in the top left-hand corner. Okay? Let's do one more problem and we will be done with this lesson. 18.5. You have negative 3 plus xmy minus y minus 5 plus 8y mx minus 3y minus 14. Again, how many terms we have? We have to combine them. 1, 2, 3, 4, 5, 6, 7. We'll have a constant here. We have a constant here with no variables in here. So I know I can go ahead and combine those. Negative 3 minus 5 minus 14 is a minus, 8 and 14 is a negative 21. So I'm going to go ahead and do that now. And it doesn't matter which order. You can just, a negative 22. Okay. Then I'm going to look. This is x, m, y. Oh, I have y, m, x. Those are the exact same. They've just flipped the order. But they have the same variables to the same power. So I've got a positive 1 and a positive 8. So that's a plus 9x and y. I don't care which order you put the variables in. Then I've got a negative y and a negative 3y. So those are the same, and I've got a coefficient, a negative 1 and a negative 3, so it's minus 4y. And simply, that is your answer. Negative 22 plus 9xmy minus 4y. So your homework is to do practice problems A through B. See you in class.